concept reduces the drag at transonic speeds, allows the airplane to fly faster and farther.
We've actually done aeronautics research for over 100 years. So NASA's predecessor was the National Advisory Committee for Aeronautics, the NACA Field Laboratories, and became part of NASA. And we've continued that tradition.
They developed a lot of the theories for the people they had back there. They developed wind tunnels. We ran the wind tunnels actually 3 shifts a day because there was that much demand for the data from the companies. And that's who we were doing it for. We had lady computers who reduced the data for us.
Ready to launch now.
The X-15 was, in many ways, the ultimate research tool. The very first aircraft to fly into space and come back and land horizontally on a runway.
We had to make the engine run in order to make the plane fly. It had to be dropped from altitude, it had to be started at altitude, and it had to have stable combustion, and we made it work.
It was very much an experimental, one-of-a-kind laboratory in the sky to investigate the next great hurdle, which was hypersonics. And that's a problem we're still working on today.
So we've always been trying to go farther, faster, higher. That's what mankind has always wanted to do, to explore. That's what NASA does, we explore. And now NASA's looking at a new X-plane so that we can make it a little bit easier to get across the country, about twice as fast.
And the innovation there is actually the shape of the aircraft so that we can enable supersonic flight over land, and that'll open up a whole new industry.
Here we are looking at how do we take all of those things that we've learned historically and place them in an aircraft that can actually fly faster than the speed of sound without creating the sonic boom. And if we can accomplish that objective, then people all across the United States, and in fact all across the world, will be able to fly faster than the speed of sound, and in fact they could fly multiple times the speed of sound without disrupting communities on the ground. We want to be at the very leading edge of technology when it comes to supersonic flight.
When you look out that window and you see that winglet, that was developed originally by NASA. There's so many things that NASA has done that we're with you when you fly.
The computers used on the space shuttle, the prototype of those computers were actually flown on the F-8 digital fly-by-wire airplane.
80% of the world's commercial airliner fleet today use that same technology in order to fly their aircraft. And almost all the military aircraft that are made today.
I remember the first time I was flying an F-18 Hornet, I was in a bit of turbulence and I thought I was holding the airplane steady and my flight controls were moving. Well, those technologies and those capabilities were developed by NASA.
Electric propulsion is really just opens up the playing field for what you can do with airplanes. Vehicles that be an air taxi type vehicle where 2 or 3, 4 people would travel across a downtown area and be able to get to a destination much quicker than being stuck on the freeway. And so it's going to create all new types of designs for vertical lift, transitioning to forward flight. And the predictions are that we'll be 3 times more efficient.
Unmanned aircraft systems follows in a long line of technologies that NASA always is pursuing to improve the quality of life for your everyday person, like to examine bridges or buildings that perhaps were damaged in an earthquake, find out where the damage is, could do that by never having to actually go into the building or walk on the bridge. So that makes it safer for people.
RTP straight in. NASA 836 registry.
For 60 years we've been exploring. We stand on the shoulders of giants that came before us. They figured it out and we take it a little bit farther, and a little bit farther. It's what we call pushing the envelope when you're a test pilot.